Okay, I'm trying to talk without the regular microphone, so excuse me if you can't hear me well, but I'm not good behind podiums. I like to walk around. And if I get a little bit boring, like Harry said, don't throw things at me because I'm pretty sensitive about that. But I appreciate Harry's introduction and what we've done. Today I'm supposed to be talking about technology, okay? And honestly, I think we're more here to talk about money instead of technology, okay? And what we can do for Puerto Rico. Because when you talk about technology, you can only get so far, and only a certain amount of people can understand everything to the full depth of what it is. So I think it's more important to know what we can do. So basically, our production process starts with, with two main products. Okay, we're going to be focusing first on mixed shredded tires, which everybody knows, everybody that lives in Puerto Rico knows that it's a problem here in Puerto Rico, but not only in Puerto Rico, it's a problem that's worldwide. In the U.S., our folks that are coming from the U.S., they're getting their raw material for free because everybody wants to get rid of it, okay? There's also a certain amount of plastics that cannot be used for recycling, so we're going to be using those plastics too. Our raw material basically is a problem for many societies. And I'm going to do a little bit background. Back in 2006, when there was no refineries, like Harry said, two gentlemen and myself, we started the first biodiesel plant in Puerto Rico. Because we thought, so much oil is coming to Puerto Rico, and there must be a lot coming out. To our surprise, most of the oil, we consume it, and there's very little left. But we started the first biodiesel plant of the Caribbean called Biodiesel and Fuels of Puerto Rico. And my associate, Miguel Jimenez, he opened up the second one in the Gulf Coast in Colombia. So we have a common background coming from biofuels. And in 2011, I was fortunate enough to sell my plant and move to other stuff. And that's when I thought, tires, plastics, only 18% of the plastics are recycled in Puerto Rico. The rest either goes to our municipal dumps or end up somewhere else where we don't want it, okay? So looking at that, I thought, that's a good feedstock. There's enough in Puerto Rico to sustain a good commercial incentive. And at the end of the day, like I said, I think everybody here has a common denominator, and that's basically money. And we're going to be talking about technology, but we're going to be talking also about mathematics and money, okay? And here's how we're going to do it, okay? We take our containers, and we put our feedstock inside. Those containers are then lowered inside our reactors or boilers, okay? And heat is applied. Basically, that heat is applied for 9 hours, okay? Within those 9 hours, what's happening is that most of the fractions, or let me talk in less technical terms, most of the components, that material that's in there is going to be turned into gas, okay? There's going to be a gasification occurring. That gas is going to be done at a low temperature in a vacuum, okay? The difference between applying heat in a vacuum or in an atmosphere is that in an atmosphere, you have oxygen. When you have oxygen, you produce combustion. And that's something you don't want because you're going to have a black smoke coming out if you do that. When you do it under a vacuum system, you don't have combustion, so you're doing a thermochemical reaction inside, which is turning it into a gas. But we do it at a low temperature so that we can get more liquid out of it, okay? Once those 9 hours are done, we end up with three main products, okay? We end up with a fuel oil, which is a pyrolytic fuel oil. I don't know if any of you have heard of it before, but it's a very heavy stuff. In the US market, they call it bio-crude as well, because it comes from renewable sources. It comes from a waste, okay? Also, we're getting pyrolytic carbon black. Mark, later today, is going to be talking to you about the differences of carbon black and all that. But basically, we're going to be producing like an N660, and that's basically used for reinforcement in tires. And also, we get the steel from the radial tires and different areas where you have steel attached to the plastics and the tires. Those three components, the last two are already finished. So those are finished products. We send to recycling the steel, And the carbon black has a great market in the US for reinforcement of tires and resins. And I don't know if you know that, but it's also used for some plastics. They add carbon black to it so that ultraviolet light does not degrade them, okay? So that fuel oil, we basically take it to our process, okay? And in our process, I'm going to try and explain to you very simply how it is. We use cavitation, okay? I'm sure to some of you, you haven't heard cavitation before, but basically cavitation is something that exists naturally in the world, okay? It happens in river streams, anywhere when a liquid changes pressure, you can have cavitation. And cavitation basically is negative pressure bubbles that are formed in that differential pressure. And that was discovered by Bernoulli back in the 1700s. So that's something really old technology. So we're not talking about space science, even though Andres likes to say that we're going to space with our technology. But it's very simple. The only difference is that we're applying an intentional cavitation to a liquid inside a special cavitator, which we designed, and it's done at 500 atmosphere pressure. Okay? So that's the only difference of what everybody has done in the past and what we're doing right now. When that happens, we basically, let me go forward because you're going to like these little thingy. We mix that fuel oil with additives, okay? In this case, we're using water as an additive, but we're also using other things to react because we found out that when we have that explosion and that ultrasound wave is created when those bubbles collapse, you enhance chemical reactions. So basically what we're obtaining is we're obtaining two things. We're obtaining a new fuel that has more hydrogen in it and less carbon content. So when you use it, you emit less CO2 to the environment. But we also have another thing. We basically remove heavy metals and we remove sulfur from the fuels. Okay? So has anybody heard about MATS? MATS is a new EPA compliance that most of the power plants are not complying with it, that they're using bunker fuel. And it's called mercury and toxic substance. Okay? That's MATS, M-A-T-S. And basically, with our technology, we can help comply with MATS on heavy fuels. Also, by increasing the hydrogen content, when you use it, your emissions of CO2 and CO are less. We've already presented this to the EPA when Jose Font, thanks to Edgar Hernandez, and they saw this as a great opportunity to improve on the quality of our fuels worldwide. Also, our technology is fully patented. We received the patent last year. My co-inventor and myself, Miguel Jimenez, we worked a lot of hours to get this done, and we finally obtained a U.S. patent. Okay, so basically, you saw the first slide. The fuel oil comes out pretty dirty. When we pass it through our technology, we clean it out. We take the contaminants out, and we enhance that fuel oil. But when we take that fuel oil that we obtain after our patent, and we rectify it, rectification is distillation. I'm sure everybody in high school had to do distillation of water and turn it into gas and then distill it and turn it into water again to get everything out. Well, this is something similar. But the only difference is that this biocrude, you're taking it. Am I boring somebody? No? Okay. You're taking it and you're basically taking the fractions out of that biocrude. Okay? And here are the fractions that you're going to be getting. You get bitumen. Okay? Bitumen is used in the asphalt industry. It's used in the roofing industry. It's used in various industries as a good thermal binder and also as a waterproof substance for roofs. Okay? We also get a low cetane diesel, which we can further refine to get a higher octane, a higher cetane level. Cetane level is to diesels what octane is to gasoline, just to give you an example. And we have a high octane naphtha, okay? That high octane naphtha, until recently, we didn't know that we can actually produce avgas from it, okay? Avgas has more or less the same octane level than than that naphtha. And what we have to do is basically a couple of steps more. And one other thing, imagine a fuel that you can produce it at 70 cents, paying for your feedstock, and you can sell an avgas at $6.50. That's a market value right now. So you just do the math, and that's why we're talking about money and math, not only technology. Because technology that doesn't make sense economically, I don't think has many room for the real world. I think you have to create technologies to improve, where you live and solve problems, but also to make an economical sense and not have to burden the government or everybody else to have to pay for the solution. So that's all accomplished through Resynth technology.